A great presentation around what Microsoft's doing in the healthcare space. So here you go, David.
Fantastic. Thank you very much. And it's an honor to be here. Very much to share ideas with you, both from the Microsoft blockchain stand and the HIM blockchain task force. I'll share some perspectives and ideas from that. We'll have some good time for Q&A at the end. So I think this will be a very interactive session. We've got small enough. Okay. There's kind of three facets. I don't know if there's another mic. This one might be low on that. All right, thanks. Hopefully that's a bit more reliable. So there's the ICOs and fundraising facet, there's the Bitcoin and cryptocurrencies and crypto tokens facet, and then there's the enterprise use cases and enterprise value. We're really going to focus on the last of those. There's a little bit of intersection between enterprise use cases and values and the cryptocurrencies and crypto tokens, but we'll mostly focus on the enterprise value. So we're looking at this in layers, right? Most industries are at layer 0 right now. And so I'll share some perspectives from healthcare because I'm mostly focused on healthcare, but what I'll share here is generally applicable. So in layer 0, we've had a huge amount of digitization of data over the last decades, right? But a lot of this data is living in silos, and there's a huge amount of untapped potential to share that data in a secure, targeted way to drive business value. Not to share all the data, just the data that makes business sense. So layer 1, here comes blockchain. And blockchain can provide that platform to do secure targeted sharing of data where it makes business sense, right? Now that's a very data-centric use of blockchain. In layer 2, we start to add smart contracts. And I'll show you in a minute how, like, if you're using blockchain just as a data sharing mechanism, you're still relying on the enterprise systems around the periphery of the blockchain to do all the compute, to do all the executable code. But smart contracts give us an opportunity to move some of that executable code onto the actual blockchain. Why would you do that? There's a variety of reasons: performance, efficiency, reliability. You know, if you're relying on leaf nodes of the blockchain network, if they go down, then you're stuck, right? But if you move that executable code onto the blockchain, you get that code executing in a much more reliable, decentralized manner. So that's smart contracts. Now, layer 3 cryptocurrencies and crypto tokens enable new commerce and incentive systems. So one of the things you run into with an enterprise use case of blockchain is this sort of asymmetry problem where inevitably you get organizations of different sizes participating in a consortium around blockchain. And you end up with this fairness challenge where one might think, well, why are we putting all our data on? We're 10 times bigger than this other one. We're just putting a little bit of data on. And so cryptocurrencies, crypto tokens give a way of solving that asymmetry problem where organizations that participate get rewarded proportional to the value that they contribute, right? So it solves that asymmetry problem. Cryptocurrencies and tokens can also give us a mechanism to incent collaboration and to incent engagement and compliance. Like in healthcare, compliance is a big thing, right? Getting patients to engage with their healthcare, take ownership of their healthcare, comply with their treatment plans. You can incentivize that with things like crypto tokens in a really interesting way. So artificial intelligence and machine learning is layer 4. There's fantastic opportunities around these with blockchain. I do a lot of speaking on that. Basically, the gist of it is that any task that can be done better as a consortium is an opportunity for blockchain. Where AI and machine learning struggle is they're incredibly data hungry. If you source them and feed them only from one silo in one organization, you are going to be stunted. But if you can source data from across the consortium, right, provenance information, you can keep audit trails, you can have shared models, you can share test results, you can share validations of test results, you can evolve new AI machine learning models, much more powerful models, much faster than you could with each organization going it alone. So how many people feel really savvy with blockchain sort of technology, and how many people are just sort of starting off? Okay, so I see probably about a third of people are very savvy. So I'll just touch on this briefly for the benefit of those that are a little bit newer to the technology side of blockchain. So as the name implies, it's a chain of blocks. We've got 3 blocks here. On the blocks you have data. You decide what data you put on the blocks. You decide what sort of interoperability standards you use. Those are super important. You don't need to invent interoperability standards. Usually interoperability standards already exist. You should leverage those to the maximum extent possible with blockchain. But you have data on these blocks in whatever standard you're using from an interoperability standpoint, and this hashes of that data. And the hash is like a fingerprint of that data. The hash is really key to blockchain. It helps protect the integrity of the data on the blockchain. But the hash of a given block is a hash of the data on that block plus the previous hash codes. So this introduces the notion of chained hash codes, and then from this comes the concept blockchain. And one of the very, very important characteristics of blockchain is this immutability, that when data goes on the blockchain, it doesn't change. Just let that sink in for a moment. Data, what goes on blockchain stays on blockchain, doesn't change. Well, what if my data needs to be updated? Well, you can put a new record you can append it to the end of the blockchain, and that record can supersede the original, but all the history of the blockchain remains. It's not an accidental sort of technology, undesirable technology byproduct. The immutability is a very intentional characteristic of the blockchain, which is super important for building trust. If you have a consortium working around blockchain, and they all have access to a shared ledger, and any one of them could change any record at any time, and nobody could figure out, what did that record used to be, or who changed it. So this immutability and this sort of audit trail and identity and access management that goes around that is a super important intentional characteristic of blockchain. It's really important to build trust. So these blocks chain together, form the shared ledger, and we have this blockchain node sitting on top of that. Think of the blockchain node as this executable thing, this process, if you will. It's sitting on top of the shared ledger, and its primary mandate in life is to maintain the consistency and validity of the shared ledger, consistent with all other copies of the shared ledger maintained by all other blockchain nodes in the blockchain consortium network. And so we have this decentralized network. Why is it decentralized? Because there's no central node. If you kill any of the nodes, the other ones will live on. When the one that you killed comes up, it will heal. It will come up to speed with the shared ledger. So it's decentralized. That's a really important concept from a reliability standpoint. Okay? There's no single point of failure. So it mitigates risk of denial of service attacks or other attacks on availability. And the decentralization is also very important for another reason. That is fraud prevention or fraud mitigation. And so collusion is rampant across industries, right? All these different kinds of fraud. In healthcare, we've got prescription fraud, medical identity fraud, financial fraud, occupational fraud. Fraud costs healthcare probably more than 10% per year. That's an enormous amount of money, dollars. And if we can help mitigate that, we should do that to help reduce the cost of healthcare. And so the decentralization, another important concept in blockchain, and the immutability can really help mitigate fraud and mitigate collusion, which leads to fraud. Okay, so a little bit more on the technology side. So here we have 4 enterprises, A through D. Each of those organizations has enterprise systems, the green blocks, and they have a firewall. They have their internal firewall, which is the red dash line. The blockchain is this B2B middleware sitting in the middle that facilitates, again, the secure targeted sharing of data where it makes business sense. So these blockchain nodes are connecting to the enterprise systems, right? So think of blockchain as a sort of back-end B2B middleware. It generally doesn't have a user interface. What is the user interface to blockchain? It's the enterprise systems. Or if you're going to put a mobile app in front of it or a website in front of it, you can do that, but the blockchain connects into the back end of those architectures, like the back end of the servers. So blockchain is kind of like this data superhighway, right? And secure targeted exchange of data where it makes business sense. And the blockchain nodes are the on-ramps and off-ramps to that highway. So I can find my laser pointer here. Anyway, the on-ramp and off-ramp to this blockchain superhighway is the blockchain node. We've got to make sure that the availability of that blockchain node is protected, right? Because although the network itself is decentralized, and if any node goes down, the network lives on. If I'm organization B and my blockchain node goes down, I've lost connection to that blockchain network, right? So don't take it for granted that blockchain is reliable. You need to still protect the reliability of your blockchain node, and we can use standard techniques like redundant nodes across availability zones, load balancing, automated failover, all that good stuff. The last important point I want to make here is that, and I'm just the messenger here, this is not blockchain religion, but the vast majority of blockchain we're seeing in enterprise is using private consortium blockchains. What does that mean? So it's not a public blockchain like public Ethereum or Bitcoin. This is, and those have merit in their own right, but private consortium means every participant in that blockchain network is well known and highly trusted and has a business need to know. And so in healthcare, we run into HIPAA and things like that. You can't just put healthcare data in a place that anybody can see it, right? I mean, it's authorized access only. And so this is the reason a lot of organizations and consortia are starting off with private consortium blockchain. That's not to say that those consortia will grow over time. Like, it's not either or, it's not private or public. Over time, those consortia will grow bigger and bigger, and they'll kind of move on the spectrum closer and closer to public. That said, there can be some corner cases that lend themselves really well to public blockchain, like in healthcare, even you've got like CDC type, World Health Organization type use cases where you're putting aggregate, not privacy sensitive information about, pandemic or virus outbreaks, that kind of thing. Okay, so what does it look like from a deployment standpoint? So we have these blockchain nodes, right? And blockchain is really a very foundational sort of platform technology that's running on the internet. And it's really important that it have a heterogeneous deployment architecture. What does that mean? It means those blockchain nodes could run like on premises inside a DMZ of an organization, or those blockchain nodes could run in the cloud. They could run in different clouds. They all have to speak the same consensus protocol. They have to know how to communicate with each other. The consensus protocol enables the nodes to communicate with the other nodes to ensure the consistency and validity of the shared ledger. Okay, so here we just have a bit of a zoom in of the a cloud deployment of blockchain. You can see the blockchain nodes across the availability zones. But you can see another important point here is we talked about how blockchain doesn't really replace enterprise systems. It connects to those enterprise systems and facilitates the secure targeted sharing of data where it makes business sense. Blockchain is also very synergistic with other types of IT infrastructure. So on the front end of a blockchain, you're going to be queuing up transactions to batch those transactions onto blocks that you're appending to the blockchain. So blockchain is very synergistic with message queue type infrastructure. On the tail end, you're going to want to do high-speed search and read of the shared ledger. Well, blockchains aren't really good at that. So you're probably going to want to index the data on the shared ledger into a database and facilitate that high-speed search and read. You're going to want to be doing backup and restore, business continuity, disaster recovery. You're going to want to do analytics, AI, machine learning. So all of these things are synergistic with blockchain. Blockchain is this new little cog in the middle of the consortium. It's not the only thing, it's a tiny part of the big machine consisting of all the other IT infrastructure and all the other enterprise systems that connect to the blockchain. That's the way we're thinking about it. Okay, so when people ask me, why blockchain, right? Because a lot of times we talk about blockchain and at the end of the day people say, well, that's nice, but why can't we just use a database? Right? We get that a lot. So one of the use cases I use is, look, we've got these silos, we've got all this data that's being collected, arguably hoarded, a lot of companies sitting on top of vast troves of data, not wanting to share it with anyone. And some of that data is rightly private and needs to be kept in the silo. But a lot of that data is common data and it's not business differentiating. And every one of those organizations, A through C on the left, is incurring multiple times the maintenance cost of that data. Look, storage of data is cheap, so storage is not a huge issue. But every organization that collects common data, like in healthcare, when you go to a healthcare facility, you all know about filling out the form, right, when you first go there. And you have to do that with every new facility you go to, and it's very cumbersome, and they have to key that data in, and errors get made, and it really degrades your healthcare as well as your experience. What if there was a way to put that common data on the blockchain so that it didn't have to be collected and maintained in all these different places at n times the cost? Rather, the common data, which isn't business differentiating, because you don't go to a healthcare facility because they say, come get your healthcare here because we maintain your address information better, right? What if that common data could move onto the shared ledger and be maintained at 1 times the cost? When we talk about reducing the cost of healthcare, why don't we stop maintaining the same data like hundreds or thousands of times, over your lifetime, all the facilities you visit. Put that data on the shared ledger. It gets updated by one member of the consortium. It ripples in real time to all members of the consortium, and you have one times the maintenance cost. You also eliminate inconsistencies, right? One of the problems you have where maintaining common data redundantly like that is it's done with various degrees of accuracy. And you end up with mismatches in data. And when you have mismatches in data, you end up with friction. Like in healthcare, if the provider record of you differs from the payer record, like a healthcare insurer record of you, your claim doesn't get paid. And so, the inconsistencies of data get eliminated because the updates to the shared ledger are rippling near real time across the consortium. That's a huge benefit of blockchain. So, if you end up with that question, why blockchain? Why not just a database? How I've heard consortia responding to that, especially in healthcare, because that's where I work the most, is let's think about it. If we're going to pool our common data and we're going to put that in one place, is it one of the consortia members? Well, that's not fair. Why should we put all our data in one member, right? One member organization? Or is it going to be some intermediary? Does that intermediary exist? Is that going to represent extra cost, extra delay, a single point of failure? Do we have to start up a new intermediary? What kind of extra cost and delay is associated there? This is why people are, and consortia of healthcare organizations, for example, are gravitating to blockchain, is because it just makes sense for that common data to use a shared ledger that's naturally decentralized and naturally distributed. And it solves a lot of those fairness issues, those cost issues, those delay issues, those single point of failure issues. So blockchain really is a missing cog, certainly in healthcare IT, but I think in a lot of information technology across different industries. It's this new little cog in the middle, again, that's very synergistic with all these other enterprise systems that it connects to. On the back end, again, B2B middleware. And it's very synergistic with other types of IT infrastructure that run around and on top of it. So blockchain strengths, we've got secure targeted sharing of data where it makes business sense. We've got data integrity, right? The immutability of the data on the shared ledger. We've got transparency. Think about fraud, right? Fraud loves to live in the dark. So if you have a silo and you have only 3 people have access to that data in that silo, there's actually a real risk of those 3 people colluding for personal gain for fraud, right? But if that data is put on a blockchain, and it's not just 3 people in one organization, but it's multiple organizations, and the changes are apparent in real time. The transparency actually helps detect fraud a lot faster, and once fraud is detected, it can be blocked and mitigated, right? So transparency can really help from that standpoint. Transparency can also really help from a data subject visibility of what's happening to my data, and giving data subjects control over their data. I'll talk about that in a moment more. Decentralization, resilience, availability of the network, of course, and we talked about anti-fraud. Really, any type of fraud you come up with can usually be boiled down to 3 attack vectors. 1, fraudulent modification of data, fraudulent deletion of data, or fraudulent creation of new fictitious data, like new fictitious transactions. The data integrity, the immutability, and the transparency of blockchain block all of those attack vectors. So one of the things, you hear about use cases for blockchain. Anti-fraud is one of the most promising uses of blockchain. And sometimes it's something that's just baked in. Like you might do a drug supply chain blockchain for pharmaceutical. And there's lots of reasons to do that. Regulatory compliance, and operational efficiency, inventory management, etc. But anti-fraud is baked in there. It's actually really good at mitigating drug counterfeit. So how do you identify use cases and business value props? Again, it's all about the network of organizations. So if somebody comes to us and says, hey, we got this really cool idea for blockchain, one of the first things we ask them is, what is the consortium? What's the network of organizations that would care, right? Who cares, right? I mean, if it's just theoretical, I mean, is there a consortium, a network of businesses like in healthcare or other industry that would actually buy into that, right? They see the business value. So that's really important, and one of the things we advise is when you're starting off with a blockchain use case, make sure you define your consortium and engage your consortium as early as possible. Next thing is define the business value. Like, why would these organizations in this consortium do this? Why would they transact on blockchain? So be really clear on that. That's really important for buy-in, because What you'll see is a lot of casual interest in blockchain right now, but there's very few organizations who will actually connect their enterprise systems to blockchain and actually transact. What will get them over that, get them off the fence rather, is defining the business values and getting them to buy into those and getting them to participate early on. So what's the low-hanging fruit in blockchain? So building the consortium is the hardest part. So the low-hanging fruit in blockchain is defining a use case that has an existing consortium. There's an existing group of organizations that's collaborating. In healthcare, we still use a lot of faxes and emails and things that are really antiquated, even hub and spoke architectures. Blockchain can drop into these existing consortia and add value near term, right? Because if you're coming up with some revolutionary new use case of blockchain that nobody recognizes and hasn't seen before, you might have a year or two of runway before you've got a consortium sufficiently bought into it that they're willing to actually transact. It's better to actually prove it out on an existing use case with an existing consortium, get a foothold, and then growing the consortium from there is easy. Why would they grow? It's not that they think blockchain is cool, it's incidental, right? They're growing, the consortium's growing because of the business value. And it's really easy to stack on additional use cases once you've done your first use case of being successful. So here's some of the use cases on the line items that we're tracking from a healthcare standpoint. The provider credentialing one, second from the bottom, is actually really close to the use case that Phil described to us earlier for the education. Think of doctors having an MD or nurses having an RN, and they have to be credentialed by every single organization they go to, and then on a two-year recurring basis. There's a huge amount of redundant effort there. What if they could have their credentials on blockchain and have the verification, the attestation of those credentials on blockchain, so that if the doctor comes up to be credentialed at a certain health system, that health system could just look at the blockchain. Oh, I see their credentials there. Oh, I see this other trusted peer in the consortium validated them last week. We're good. Never mind that 5-week delay. Let's just move forward with another cost. So you see the use cases on the line items, and then the columns are really the business values. And you can see one of the strongest business value that's driving blockchain, certainly in healthcare, but in a lot of industries, is cost reduction. If your use case for blockchain has a strong cost reduction value proposition, it's likely to get traction a lot sooner than some of the other ones. So building a consortium is the hard part, getting buy-in, getting trust. We talked about that. I don't think there's a whole lot more to add here. On the security side, blockchain, when it first came along, I served for over a decade at Intel as the Director of Security, Privacy, Compliance for Intel Health and Life Sciences. And while I was there, blockchain came along, and my manager said to me, get a handle on this. It's being asserted as sort of a silver bullet or panacea for security. And so that's how I first got into it, and I went deep into that. And I can tell you that blockchain is really good at certain facets of security, in particular integrity and protecting data integrity with the immutability. And it's really good at protecting availability of the overall network. But where blockchain needs a little bit of help, surprisingly, is on the protecting the availability of individual blockchain nodes and protecting the confidentiality of data. Don't take that for granted, right? In any security profession, any security professional will tell you, you've got to take a multi-layered, defense in-depth approach to security to have effective security. It should be holistic, administrative, physical, and technical security. It's no different for blockchain, right? One of the levers that you've got to pull for or safeguards you can use to mitigate risk to confidentiality of data on blockchain. Well, first of all, what data are you putting on the blockchain? Remember that data is going outside the firewall of the organizations that are participating. So you want to be frugal, you want to be minimal but sufficient. Not let's put all our data on blockchain and figure out later how to make business use of it. Rather, what is the use case? And then for that use case, assuming blockchain is this little cog in the big machine, what's the minimum but sufficient data I put on blockchain to support that use case, field by field? Does this field need to be on blockchain, or can it live in the enterprise system that's connected to blockchain? And so be minimal but sufficient. The other big opportunity for those cybersecurity professionals out here is, we know that there's a lot of risk from sort of business associate networks. If you're like what we call a covered entity in healthcare, like a hospital, and you have lots of other companies that you work with, and they can access protected healthcare information to render their services, there's a lot of risk of them breaching your data and tarnishing themselves, but you as well, right, as the hospital. We have the same risk in blockchain. You've got a consortium, you put data on the consortium, some other organization pulls that data off the blockchain, and they have a breach, and it affects them, and it affects the consortium, and it affects all the organizations in the consortium. It tarnishes them, right? So to build trust, to connect to blockchain networks, you really need to think about adequacy of security, adequacy of compliance. Tools like risk assessments, audits can detect, is each organization in the consortium, do they have adequate security? If they don't, let's identify that up front, let's mitigate that, get everybody up to an acceptable level. This is actually an important trust building mechanism across the consortium, right? Because one of the things the CISOs of the consortium members will be thinking about is, okay, we're secure, but is everybody else secure that's connecting to this blockchain and accessing the data we're putting out there? So there's this concept of adequacy. On the privacy side, blockchain is really interesting in that, there are privacy risks, like risk to confidentiality we talked about, but blockchain is this double-edged sword, right? It's actually a wonderful new tool to drive privacy and empower data subjects with their privacy in ways not possible before. Phil talked this morning about how you can consent or opt in with blockchain. You can revoke consent or opt out. As a patient or as a data subject, you can see what data is available on me, who's accessed it, have the ability to amend it, or even request to be forgotten, etc. So blockchain gives us wonderful capability to boost privacy, not just the privacy risk. So compliance, you want to be frugal about what data you're putting on blockchain, especially from a PII and PHI, or protected healthcare information standpoint. Sorry, PII, personally identifiable information. Anything that can locate you, identify you, or be used to contact you. There's data sovereignty and transporter data flow type issues. If you start off with your consortium in one state and then go national and then go international, you end up with data in that shared ledger flowing across jurisdictions, and you end up with this data sovereignty transporter data flow issue. So keep it frugal, keep that PII and that PHI off of the blockchain if you can. It can live in the enterprise system. What goes on blockchain is an opaque, meaningless identifier for a patient that if it gets breached, it's not the social security number, it's not the date of birth, right? It's benign. So the big system needs to be able to resolve PII, but the blockchain itself doesn't. That's a very, very key concept. The location of blockchain nodes is key. You got to think about compliance not just from your pilot, but where could you grow if you grow internationally long term? Think about compliance from that standpoint. If you have to comply with GDPR, think about that up front. You might have to at some point. So integration and interoperability are a challenge with blockchain. The good news is you don't have to start from scratch. Use whatever standards are out there in terms of deciding what sort of formats and interoperability standards will be used with the blockchain. Blockchain also is not everything, right? Like, one of the use cases for blockchain is health information exchange. So what you put on blockchain could just be the metadata about records, like an x-ray you had, and a pointer to where that x-ray lives, and a hash code to verify the integrity of that x-ray. But the actual x-ray doesn't go on blockchain. That's protected healthcare information. That's a super heavy data artifact. You don't want to be putting heavy stuff on blockchain. That needs to be replicated around all the shared ledger instances, right? Blockchain's for lightweight data, like metadata. So if you put that kind of metadata on blockchain, then organizations can discover it. And if they want that data, they can reach out to the source organization through the pointer. They can retrieve that data. They can verify the integrity of that data with the hash code. And they're good to go, right? And so you avoid all the compliance issues, the privacy risks, the security risks, compliance challenges by keeping that particular data off of the shared ledger. So performance, throughput, scalability, don't take it for granted. When you have your use case, think about how many transactions per second, how many blocks per second up front. Blockchains, block throughput rates are actually in the realm of hundreds to thousands of blocks per second. Now you can batch transactions onto blocks, so you could put 1,000 transactions onto one block, so you could potentially get 1 million transactions per second. But blockchain is not nearly as fast as the enterprise databases that we're used to today. So you need to think about your use cases. Your use case super chatty in terms of high performance, high throughput requirements. Not all use cases lend themselves to blockchain because of performance constraints. Interestingly, blockchain nodes are not CPU bound. In enterprise consortium, private consortium use of blockchain, there's no notion of mining. So forget about all the Bitcoin isn't green stuff you've heard. That doesn't apply to enterprise use of blockchain in private consortium where you don't have mining. Blockchain nodes are also generally not data